This is Mary Peters with my Lab 9, the Physics of Extreme Sports with Ropes 2, for Physics 2211, Section M02. The main objective of this lab was to first examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. A video of the spring mass system was analyzed using tracker, and the position of the mass was determined over the varying time interval. The motion was then modeled using the same techniques and fundamental principles explored in the on-campus lab, including the momentum principle and the energy principle. The main result: the tracker position data was placed into the code so that a comparison between the model predictions and the actual position could be made. In the VPython video, the blue ball represented the actual position and the yellow ball represented the model. Throughout the video, the two balls are very close. Therefore, it can be concluded that the model is a good prediction of the motion. Now I will run my code so that you can visualize the difference between the experimental and model positions. The blue ball represents the experimental data, and the yellow ball is my model. So because they are constantly very close to each other, my model is a good prediction of the experiment. It can also be seen that the model is a good model of the experimental data by analyzing the position graphs. The top graph represents the y position versus time, and the bottom the x position versus time. The red represents the model, and the green represents the experiment. Many physics models and principles are represented in the code. There are two forces acting on the mass: the force of gravity and the spring force. The force of gravity points in the negative y direction and is equal to the mass times little g. This force of gravity equation can be used for objects near the Earth's surface. L is defined as the vector pointing from the attachment point of the wall to the ball. It is found by taking the position of the ball minus the spring position. The magnitude of the L vector is the length of the stretched spring. Therefore, the stretch of the spring can be found by taking the magnitude of L minus the initial length of the spring. The magnitude of the spring force is equal to the stretch of the spring times the spring constant. This magnitude of the spring force can be multiplied by negative L hat to represent that the force is in the direction opposite of the stretch. Because the spring force and the force of gravity are the only two forces acting on the ball, F net is equal to the sum. The two update formulas in the loop are the update of velocity and the update of the position of the ball. The update formula for the velocity of the ball is derived from the momentum principle. The update form of the momentum principle is the final momentum equals the initial momentum plus F net times delta t. If you divide by the mass in every term, you will get that the velocity final equals the initial velocity plus F net divided by the ball's mass times delta t. Momentum divided by mass is equal to velocity when the velocity is much smaller than the speed of light. Another major fundamental principle modeled in this lab is the energy principle. The energy principle states that the change in energy of the system is equal to the work of the surroundings plus Q, where Q is the energy transfer between system and surroundings due to a temperature difference. In this lab, Q is equal to 0 because there is no energy due to a change in temperature. In our experiment, the system was the ball, the spring, and the gravity. Therefore, the surroundings contain nothing significant. Because Q is 0 and the surroundings have nothing significant, the work done by the surroundings is also equal to 0, and delta E of the system is equal to 0. Therefore, the sum of the change in kinetic, spring potential, and gravitational potential energies of the system is equal to 0. Here's my code for the initial kinetic and potential energies and the energy changes in work for the system. Note that the spring is in the system, and the change in spring potential energy is equal to the negative work of the spring. This is because change in potential energy is equal to the negative of the work done by interior forces. The work done by the spring is equal to the dot product of the spring force times the change in position. the change in position of the ball is equal to the ball's velocity times delta t. And this term can be found in the position update equation, which is right here. The first what does it mean question is, with your new choice of system, determine the work done by the surroundings. Is the energy principle satisfied? In this graph, the change in kinetic energy is represented by the red. The change in spring potential energy is represented by blue. The change in gravitational potential energy is represented by green. And the sum of all of those changes, which is equal to the change in the energy of the system, is the yellow line, and it is equal to 0. So therefore, the sum of the energies, change in energy of the system is equal to 0, which is represented by the energy principle. The second what does it mean question asks us to compare the period of oscillation found from examining the x component of position with that of the y component position. I found the period by taking the time from peak to peak for the position graphs. The period for the y position graph was 1.51 seconds, and that of the x position graph was 1.61 seconds. They do not differ significantly. This can be explained because t is equal to 2 pi times the square root of m over the square root of k. 2 pi are numbers and they're constants, and m and k, the mass of the ball and the spring constant, are also constants. The third what does it mean question asks us to change the origin and then look at the resulting change in the energy plots. Because potential energy has to do with interacting objects, you get different values for the spring and gravitational potential energies if you choose a different origin. However, the change in all of the energy quantities stays the same because the energy principle states that the change in energy of the system equals the work done by the surroundings, and the system did not